All right, we're going to go ahead and get started. I'll let folks in as they come in. All right, so thank you so much for joining us, everybody, for the White Tank Mountains Regional Park plant inventory update with Cass Blodgett. We are really excited to hear about all his findings and the findings that him and the team made while they were out hiking the White Tank Mountains. He is actually a garden volunteer who took the budding botanist training that was given by the Plant Atlas Inventory Project and also the Casca Budding Botanist Program. He's an excellent, wonderful, wonderful amateur botanist who is a wonderful resource for us and has done a really magnificent job. So we're really excited for all the work that he's done, not only for us, but also for the county park system, of course, since this is really valuable information. And so I'll go ahead and turn it over to Cass so he can explore and let us know what he found and all the really good stuff that we're gonna hear. So just really quick housekeeping. Again, guys, if you can stay muted throughout the event, that would be really fantastic. We have the chat function, so please go ahead, and if you have any questions throughout the talk, please go ahead and put those in there, and we will have time after Cass is done to answer any questions. So all right, thank you so much, and we'll go ahead and get started.
All right, well, thank you. And I didn't do this myself. I had a partner in crime, Don Goldman, who is a long time Desert Botanical Garden volunteer. I'm sure that there's people that know her on this in this group. She's not in town. She's off traveling and isn't able to join us. But this is our work together over the last 5 or 6 years at the White Tank Mountains. I'm going to spend some time sort of introducing the project to sort of set the stage. I'm going to discuss some of the data that we've generated. This is mostly numerical, and then I'm going to do some sort of qualitative findings of observations that we've made. And I'll do a few historical comparisons, try to use my data to draw some conclusions and then end it. To start with, this project was initiated by the Conservation Alliance, very early in their beginnings. I actually don't even know that much about what Conservation Alliance does at this point, but at the beginning, they did a lot. They started things off with doing a bunch of surveys of some of the mountain preserves in the Phoenix area, and that's how I got involved, was my interest in doing that. In 2016, we started our work on the white tanks. We would not have been able to do this without great support from the White Tank Mountain Regional Park, both the staff there, the rangers, who were super helpful and accommodating, and the Desert Botanical Garden, which takes our specimens and receives them into the herbarium and helps us with processing them, and a big group of volunteers from the community around the mountain that really helped us a lot. People from both the White Tank Conservancy, but also others from the community were a part of this. Almost every trip that we took, we had company from the community with us. And so they deserve a lot of appreciation for the help on this. And special thanks to Cindy Smith, who I'm sure if there's White Tank people here, I'm sure you might know her. But she was extremely valuable in helping us navigate the mountain, and in her eyeballs in identifying actually a lot of the plants that we needed to collect, locating them. So thanks to that group. So the study areas of White Tank Mountains. I should note that at the very beginning of this, it included the Skyline Mountain Park as well. But what we found when we entered White Tanks was such a big, imposing place that eventually our attention, it was enough for us just to try and cover this area. And so while we've made some collections, maybe 250 collections in the Skyline Park, that really is kind of not part of this discussion. The mountain is a metamorphic core complex, which means something to geologists, but I don't think is all that important botanically, except that all of the soils in this mountain are derived from igneous rocks. There's no limestone or sandstone or basalt or anything like that. The elevations range from 1,300 feet on the east margin to over 4,000 feet at the tippy top. And it drains into two different watersheds. One on the east side, the slopes drain into the Agua Fria aquifer, and on the west side into the Hacienda. And what makes this an interesting study is that it's not the first time it's been done. In 1968, a master's student at Arizona State University was making his bones walking the white tanks and doing inventory at that time, and launched a career off of it. But since then, the park has seen a lot of development. The area around the park has seen a lot of development, a lot of changes. And so makes this a good opportunity, since we have now two databases that are rough equivalents of each other. we can do some comparisons and see if we can understand anything about what may have changed. Before we could start this, one of the things I had to do was establish a baseline flora. What is the baseline flora, the historic flora of the white tanks? And so what I did was I basically took records of all the collections that have been made from the beginning of recorded botanical collections in the white tanks through the year 1977, and somewhat methodically and somewhat arbitrarily called that the endpoint of the historic era, and took all of those records of plant collections and formed a plant list out of that, and I'm calling that the historic flora, or the original flora of the White Tank Mountains. That is available for all the public to view, anyone who wants to view it on SciNet. Hopefully someone at some point in one of these meetings has told you what SciNet is. It's an extremely valuable resource for anybody interested in botany or plants, not just for technical people, but for anybody. That checklist is available there. You can view it. It's linked to all of the actual vouchers of the plants that make up that historic flora. So you can see the actual plant specimens where photographs exist. And if not, you can at least see the field notes that the botanist took at the time. The area of coverage thus far, the pin drops on the Google Earth there represent locations where we've actually put our packs down and collected plants. What is obvious from that is the west has not been heavily covered, and the north somewhat, but still sparsely covered. The red outline that you see on there is my estimation of the locations that comprise the earlier study, or in particular that comprises David Kyle's study back in 1968 to 70. That I've poured over his field notes now in the form of plant labels in the herbarium for years now. So I'm pretty familiar with those and what they have to say about the landscape and the places, even though they don't have GPS coordinates. And I've walked the landscape long enough to have a feel for where he's been and not been. And that red outline is a pretty decent estimation of his old stomping grounds. So with our coverage being pretty similar to that, it's a good time to compare notes. In the future, I do intend to go to the west side and get some collections there and try and characterize that, as well as some more work in the north. And there's a few more places in the east side here where there are still some locations that are intriguing, and I want to at least see them. To some numbers for this survey. We've had 63 plus collection events thus far. We've collected 1,133 specimens. Within those, there are 312 separate identified plant taxa in that. And that's fairly comparable to what David Kyle found back in 1968. Kyle found 336 plants in his flora. The stars on those numbers, the way to interpret those is that the 336 accredited to the 1968 survey there, those were David Kyle's reported numbers. The baseline flora that I referred to earlier, that is David Kyle's taxas plus additional collections made by other people contemporaneously. Together, there's 350 total taxa that make up the baseline flora. And then the two stars next to R312 are that additional collections made previous to our arrival and some other collection, not collections, but observations made in such tools as iNaturalist that I scanned over and vetted as probable valid identifications. I've added to this as well. So our 312 may be as high as 320. In 1968, 4.6% of the flora was exotic plants, non-native plants, and today it's about 8.8%. During our survey, we added 39 new taxa to the flora. So 39 new taxa above and beyond the 350 of historically present documented plants. Of those, 30% of them are non-native plants, but 70% of them are native plants. And then again, referring to the 350 taxa in the historic flora of the white tanks, 78 of those taxa are ones that we've yet to encounter, that we haven't run across yet. And that number is a significant number, and that's sort of motivating a lot of the rest of this discussion. Our taxa accumulation lists of the respective projects are shown here. As you collect plants in a region, your initial collections, everything's new and everything's a new taxa. But as you make more and more trips, the number of new plants that you run across diminishes over time. And it turns out this kind of activity approximates a logarithmic curve. And so I've curve fit our own data to an approximate log curve. And what it shows is that our current trips and any of the next few future trips, the likelihood of stumbling on new taxa to add to our checklist is somewhere between 1 and 2 plants per trip, possibly 0, possibly even 3, but in that neighborhood. And then that number will continue to diminish as we do more searches in the same kinds of areas that we've been looking on this east side. So at that rate, it tells you that we're starting to run dry of new plants to find. We could compare this data with the 78 taxa not collected, and it says that there's a shortfall there that we're not going to make up. The composition of the park, it's about 50% annuals and 50% perennials. This is a very much an expected ratio for this part of the desert. But one thing you can see when we compare 1968 to 2016 is there's been a little bit of a shift toward a higher ratio of annuals to perennials. And that shift isn't huge, right? We're talking about a couple of percent here. So a greater expert may evaluate that and say that it doesn't mean anything. If you had to ascribe some meaning to it, it might suggest something about increasing aridity in the area, because increasing aridity is consistent with increasing ratios of annuals to perennials in your flora. The breakdown in terms of growth habit from firs to trees to shrubs, you see there. I don't really have much of a message there, but there it is. What we find on the landscape is that the entire plant community falls within the Arizona upland subdivision of the Sonoran Desert scrub biotic community. These are formal names with somewhat formal definitions created by a publication in 1994 by David E. Brown that gets cited over and over again. It's kind of the gold standard for defining where you're at in formalized terms that people understand and accept. But these are hard definitions to work with. So I'm going to describe this community in less formal terms that may mean more to you, that are more descriptive. In the lower hillsides of these mountains below, say 2,800 feet, are upper Sonoran Desert scrub. So this is brittle bush, the little leaf palo verde mixed cactus community. On the north exposures of these hillsides, jojoba often replaces creosote bush as the medium story plant. And on the south sides of these hills, often teddy bear cholla make their appearance, and they're very rare to see in other places, except sometimes on flat plains. The alluvial plain desert scrub, so this is on the Bahadas and gentle slopes coming off the mountains. These are where there's very thick soil development and somewhat level aspect, angles. This is creosote bush, triangle leaf burr sage communities. There's an awful lot of schismus in rainy years. Schismus grass on rainy years is probably the dominant plant in these lower elevations. Above 2,800 feet, an entirely different set of plants begin to appear. But on a larger scale, some regions above 2,800 feet form these desert grassland communities where Hilaria rigida, or big Goleta grass, forms large fields of grassland. And within that, again, on northern exposures, mainly you see the appearance of crucifixion thorn and desert agave. And quite a number of other really interesting plants make their appearance above 2,800 feet too that you don't see below. There are sheltered microhabitats in this wilderness, largely made up by large north-facing cliffs on the larger scale, and on the smaller scale by big boulders and small overhangs of cliffs. But the bigger areas harbor desert hackberry, yellow bush penstemon, and white sagebrush. These are plants that are receiving considerable shade from these cliff faces, and the soils below are receiving protection too, so water doesn't evaporate as fast, so soil moisture persists longer in these areas. These plants don't typically occur in the wide open spaces or on southern aspects. On the smaller scale, boulders and little alcoves that have a certain amount of overhang to them harbor species such as larkspurs. This is where the ferns occur, and on the edges of these is where you see the Dudleya plants in the park. Excuse me. Drainages and canyons are important plant communities here. They have drier segments and wetter segments. The drier segments are filled with mesquite and ironwood, lots of desert lavender. The wetter segments have some wetland obligates within them, yellow monkey flower, salt cedar and Bermuda grass, unfortunately, are common in the wetter segments of these canyon drainages. It's the canyon drainages also where all of the buffalo grass and all of the fountain grass are located. And that's both good and bad. We'll discuss more later, but that's where it's at. There are some areas that I regard as actual springs, and they harbor the only populations of willows that you'll find in the park. There are man-made wetlands. These are shallow drainages and depressions that are dammed off with earthen barriers. It's unclear to me whether or not these precede the formation of the park. They go back to the ranching days, or if they're post the park formation. Today, they appear to be maintained to some degree by Fish and Game to feed, to give water to the mule deer population, among other animals in the park. And they tend to be very clogged with very fine silt, and these are completely dominated by Hordeum mirinum, or mouse barley. And we have examples of secondary succession landscapes, which by that I mean fire, where fire has occurred. These you'll recognize when you're in them as being heavily dominated by brittle bush, but having a lot less of the middle and upper story plants that you see throughout the park and other places. And if anybody has a question, I think you can jump in if you want to. I have taken a particular interest in water in the park, and so I have mapped out where water is, that I know of anyway. They include these man-made wetlands, they include perennial wet places in the park, and they include places that I regard as being springs, that is permanently wet areas. So if the park is interested in this, I have that. Things that we found along the way, I mentioned earlier that we added 39 new taxa to the historically documented flora. 26 of them are native, and here is a little story about 5 of them. Centarium calicosum is a member of the gentian family. It's a beautiful little wildflower if you should ever happen to see it, and it's not likely that very many do get to see it. It was found in a wet area. It's a native plant, and it's possible that this plant was always present and just not found in 1968. It's also possible that this plant is not a constant resident in the park. The seeds of this plant are so tiny and wind-borne dispersed that it's possible that monsoon events or other wind events could carry these seeds for many, many miles. And so when these seeds happen to fall at the right time and place, you get an occurrence of Centarium calicosum. But it may be the case that in other times and in most years, it's not present at all. And so it may not be a permanent resident of the park. There may not be much of a seed bank of this plant in the park, but it will occur from time to time, at least in wet places. Miner's lettuce, Claytonia perfoliata, is also a plant that wasn't found in the previous survey and hasn't been found until now. It's rare in the park. Again, this is a wetland obligate plant, and possibly always present. There's no reason to think that it wasn't always present in the park. Perry's penstemon, this common landscape plant that we find. It's a native plant. It's in the landscape industry and very popular there. I have my suspicions that even though it's possible that this is a historic native population of Perry's penstemon, it's not unthinkable, but it seems unlikely to me. I know from personal anecdotes, walking with people in some of their favorite trails, stumbling upon Perry's penstemon and having that person confess that they threw some seed around in previous years and that those are plants that they introduced. It's possible that that happened here at the White Tanks, that somebody who's just an enthusiast wanted to see pretty flowers grow, threw some seed around, and in this particular area, Perry's penstemon grew. Nicotiana clevelandii, that's a desert tobacco species. Now there's Nicotiana obtusifolia. That is the native desert tobacco species that's most common in our area. Nicotiana clevelandii, in fact, doesn't grow in our area. This is a new find, not only for the park, but for the region in general. It's a plant of the Mojave Desert, west of the park and down into Baja. I don't have a solid explanation for why we would be seeing it here. Was it transported mechanically by somebody or something? Or is the plant just sort of on the move, as I know a few plants are in these changing times? But it's an interesting and fun find, and it's now a resident of the park. We also have Cylindropucha fulgida in the park. This is chain fruit cholla. It's a big cactus. If it was there, David Kyle would have found it. So it probably, looking at the plants that we found, this is actually a Cindy Smith find. There's a population of about 25 or so plants that on the uphill side begin with one large plant, and then sort of in a teardrop shape going downhill, there's this population of smaller plants. So in my rough estimation, maybe this got started around 30 or so years ago. I did note from my last trip to the White Tanks that this population, at least part of it, was damaged by this last fire that happened last summer. But on the north side, or I should say the west side of the White Tank Mountain Road, these plants are still healthy. Of the 39 new plants that we found in this survey, 12 of them are exotics, and 4 of them are a particular concern. These 4 plants we seem to talk about all the time, no matter what park or place we're talking about, but actually none of these were present in 1968. These are all relatively new arrivals. Brassica ternifortii is sort of everywhere in the park, but it's mostly in the lower elevations of the drainages on the lower slopes of the drainages. and it can become dominant in some of those places, especially in rainy years. The two pennicetums, the fountain grass and the buffalo grass, those are currently confined to the drainages mostly. I have found a couple of examples of buffalo grass on some of the remote dirt roads in the remote areas of the park and on the very top of the park in the antenna facility. So that's one way that it's getting transported and moved, but it is in the park from the top to the bottom, but currently confined in the drainages. That's a temporary situation. It's going to escape the drainages and climb up the hills if it hasn't already started to do that in short order. Also, Onchocyphum piloluferum. This is the stink net plant. It's the most recent non-native plant to gain attention. And the good news is I don't see it in choking numbers. I don't see it in intense populations in the white tanks like I do in some other places. But I do find it everywhere. There's no place in the park that doesn't have this plant within 100 yards of where you're standing, including the most remote places. So I don't know. I don't think anyone really knows what the future holds with this plant, how benign or dangerous it might be. It has the signs of being dangerous. We'll just have to wait and see, I guess. But we do know the dangers of buffalo grass. It's in the park. It's not escaped yet. So it's potentially manageable if action starts now. And then here is a Google Earth map where I've placed the locations of all of our observations and collections of these 4 non-native plants. And so if the park is interested in this data, you can have that too. For some historical perspective, I tried to come up with some information on weather trends, not strictly a necessary exercise since there's an abundance of data on this everywhere, but I wanted to see something a little more closely temporally, related to our time frame in this comparison, but also locally related to the White Tank Mountains. So I gathered precipitation data from weather stations dotting the Phoenix area, which is what you see in the top graph. And I gathered precipitation data from weather stations that are surrounding White Tank Mountain Park itself. And they both show similar trends, but then so do other sources of data on this. That in the time since the 1960s to today, average rainfall has decreased. By my data, it's about 2 inches plus. I took a similar look at temperature data, and while I don't have local temperature data from around the mountain, the same weather stations that gave me the precipitation data gave me some temperature data. And the trend that I show in temperature data in the Phoenix area matches this much longer range graph that I have from an online source in weather.gov. But what it says is that in this last 50 years, there's been about a 3.5 or more degree, average annual temperature in the area. And then, of course, the little inset graph at the bottom is one that's been used in lots of presentations that I've seen over recent years, and it's showing, the number of 110 degree plus days every year in the Phoenix area. So these are stressors. The decreasing rainfall, the increasing temperatures are significant stressors on this environment. But I wanted to look beyond the weather for reasons I'll mention in a minute, but looking at the aquifers around the mountain, in particular looking at the Agua Fria aquifer, that aquifer level has declined by about 250 feet since 1950 to 1990. That's the data source I have. And that's due to agricultural use over the years and the improvements of pumps after World War II. Seems like a significant drop to me, and it got me thinking about how this might impact the mountain. Where the question I was asking myself is, how does the level of an aquifer that's already underground affect the soils and the soil moistures that are banked in a mountain that's well above this valley floor in the first place? And I think there might be a mechanism for that. This is all a hypothesis that I'm spending time on with, just because I spent a long time thinking about it, and I think there could be something there, but I need to review this with the right people to find out if there's any there. But the thought process is that with a water at the a water table as it approaches a mountain rampart underground has a sort of a meniscus type of effect, which is where water seeping through these soil columns reaches saturated soils near the aquifer table and starts to back up, as the velocity of water movement through the soil slows, as there's less and less space between the soil particles for it to move. So there's a back pressure exerted by saturated soils against continued flow into the aquifer. And that kind of backs up the mountain slope a little bit. And so I'm imagining a water table much higher than that, where perhaps that effect may actually be visible on the ground in the soils above the mountain. And the reason I started imagining this is all of the remarks that I see in David Kyle's records of small seeping streams and small ponds and just a lot of water features. And if I look over my notes, I just don't see. There isn't that much to remark on in terms of water features. There are a couple, and I'll talk more about them later. But it seemed like that water was more ubiquitous in the past, and this mechanism of water sort of receiving back pressure from a higher historic aquifer may have had impacts near the surface of these elevated soil banks, and may account in part for some of the apparent decrease in water sources in the park. This is a guess. So what I tried to do is if you think about what we've done is we've collected a bunch of plants, which leaves us with a bunch of plant names and a bunch of GPS coordinates. And what do we do with those? How can we use those to tell a story? And so in order to make comparisons, what I just started to do is to say, I just need to plot things and see if a picture emerges. So what I did was I created this graph paper. It's sort of a numerical model of the mountain range, at least the eastern slopes of it, turned into a piece of graph paper that I started plotting points on. And as I started to do this, it occurred to me that what I really should focus on for one of these studies is I should look at all of the wetland plants, all of the plants that have an obligate wetland association, plants that need they either need to have their roots in water all the time or something very close to that. And so I listed the plants that David Kyle found in 1968 that fall under that category, and I listed the plants that we found that fall under that category and plotted them on this graph paper. And then I started researching, historically, where was the water in the park historically? Is there anything on that? And it's hard to find that kind of information. But one thing that did turn up is some remarks in a 2014 White Tank Mountain Master Plan update that refers back to an even earlier master plan from 1965 that asserts that there is such a thing as a willow spring, a mesquite spring, a dripping spring, and this other spring that is unnamed, and that those are real and they exist in the park. And fine, does anything back that claim up? And what does, I think, back that claim up is the abundance of these wetland obligate plants that were located near where those places were purported to be back in that time. We can see examples of bulrush, of cattail, various willows, and arrowweed in the park, and approximately in locations where those springs were purported to be. In the present day, all we have are some examples of Gooding's willow and arrowweed as perennial plants with a wetland affiliation, either an obligation or a close obligation. And so hiking through these areas over the years, what I can say is that there is such a thing as Mesquite Spring, as Willow Springs. We know that because it holds the largest gallery of willow trees in the park, about 7 specimens, both staminate and pistillate. It's a healthy population, and there is water at or near the surface just about year round. Not to be fooled by the big water tank there, the big punch bowl tank there that a lot of people may think of the springs. The actual springs are a little bit downhill from that. I've been up and down Mesquite Canyon, and while there is a wet spot there that harbors some wetland obligate annual plants, there are no wetland obligate perennials living there anymore. And there is nothing that to my eye I would describe as a spring in Mesquite Springs in that canyon. I can almost be as certain about that with Dripping Springs, although Dripping Springs is really hard to get into and navigate. So there's some places I haven't seen yet that I'd still like to shoot for. But near as I can tell, I've been through the area that has previously been described as a spring. Near as I can tell, I've been through the area where this large variety, comparatively, of wetland plants have been sampled, including, believe it or not, Fremont cottonwood in Dripping Springs Canyon. None of these plants are there anymore. There is one very small, diminutive willow tree in a single location. There is a big patch of Bermuda grass around it, but there's really nothing else there. It appears to be that there is some underground plumbing there. It appears that a willow tree did get a root into some fissure in the ground and does have water. It could be the source or one of the sources that fed a more healthy spring that was there in earlier days. That's not clear to me, but what is clear to me is what was Dripping Springs is not there now. There is a note in this report that says that concrete tanks were built at Dripping Springs to catch the water, but was later buried by a cave-in. I don't see evidence of that, but that could also be buried. That could also, the landscape could have changed enough so that isn't visible to me, or obvious anyway. But there's at least a note in the historic documentation that something happened there that affected those springs. And then I did go on a mission to find this unnamed spring. And I hiked up the drainage of Black Canyon where I suspected it might be, and did ultimately find it. And there is a spring there with above ground water all the time and a small gallery of willow trees. It's a real beautiful spot. But this is what the plants tell me about the history, and this is what the plants and my own observations are telling us about today, where the springs are in the park. Ford Canyon is an interesting discussion because while I don't call it a spring, it has historically harbored some wetland plants. It is the only place in the park where I've found arrowweed, Puccia sericea. It's not strictly a wetland obligate plant, but in this area, I would kind of consider it to be one. And there are lots of examples of wetland obligate annuals in a certain stretch of Ford Canyon drainage. It's definitely one of those perennial wet areas, but I am falling short of saying that there's a spring there.
Hey, Cass, you have 10 minutes. 10 minutes.
Okay, that's fine because I think I'm just about there. Then what I looked at was other plants that I haven't found or that I think may have changed. One of the things I suspected is that maybe the range of plants have changed. And so with a couple of examples, scarlet 4 o'clock and Penstemon subulatus, the pink circle and the red triangles. We both found those, both back in the day and today, but we found them at different elevation levels. And that may indicate that there's been some upslope shift in the populations of some plants. This is only 2 examples. That's not a lot to say to be conclusive about that, but that's something that might be worth some further study. And then disturbingly, there used to be apparently a healthy population of red paintbrush in the park. David Kyle found 4 examples in 4 different places. You have to believe that there was more than that there at the time, but I'm pretty confident that there are none there now. I've never seen them anywhere. I've been very conscious to look for them. I don't think they're there. If anyone knows of one, I'd love to hear about it and find it, but I think those are gone now. The Polygala macrodinia, a milkwort plant, he only found it kind of in one location, but I've been there and I don't see it. The Penstemon subulatus that was common in the northern portion of the park is not found at all anywhere in the northern portion of the park. And then interestingly, Calicortus kennedyi, the Mariposa lily, the beautiful orange Mariposa lily, that's actually really common in the park today. But it wasn't apparently in '68, where only 1 example was found. And it occurred to me that this might correlate to the bug fire in 1994. This approximate area that I've shadowed here is where you find a lot of the artifacts of burning plants. There's a lot of charcoal there. There's a lot of landscape that appears to be affected by fire. So it could be that one of the impacts of this fire is that a few plants may be temporarily or permanently extirpated. And it could also be that some plants, such as Calicortus kennedyi, have a response of being more plentiful. I know that Calicortus kennedyi, at least some species on some places, is known to be a plant that thrives on that kind of disturbance. So all of this sort of leads me to a set of conclusions, which are not surprising. First one is that White Tank Mountain is sort of a gorgeous, gorgeous place. It's a little Garden of Eden in the hot desert, and it retains an element of its pristineness, at least as measured by the relatively small number of exotic plants there compared to other urbanized parks. It's typical to find a minimum of 10% of the flora of a lot of these urban mountain parks consisting of exotic plants. That goes up to 16, 18% in some of the more heavily infested ones. But species richness appears to have declined over time. 23% of the historically documented taxa have not yet been encountered. I think it's reasonable to conclude that some of them are still there. Some of them we'll probably find, but a good chunk of them I don't think are there anymore. And the reasons for why this would be, I think we've sort of gone over. But we should also talk about the increased pressures on the park as it gets used more, as it gets developed further on all sides, and really need to emphasize that this mountain is receiving more exotic plants as time goes on. Some of them are really dangerous, and there is a slim window of opportunity to try and get on top of that. So after those conclusions, I have one more thing that I wanted to talk about, which was how do I use this data? What's one thing I can do with this data that's sort of beyond White Tank Park itself? And so what I did is I did another little study of 5 of our mountain parks. These are all mountain parks that have had floristic studies done in the past. So there is an historic baseline flora for each of those. And what I did was I used this handy SciNet tool and extracted many databases for each of these mountain parks, all of the plants that have been collected in the shadowed outlines you see in these inset pictures, inset maps. And from that data, I constructed plant lists for each of these mountain parks. And then what I did is I compared them. And the way that I compared them was I said, if a plant in any one plant list occurs in any of the other plant lists, I'm going to call it common. And if a plant occurs in a plant list but does not occur in any other plant list, I'm going to call it unique. And from that, you get a list of plants that are common to two or more parks, and lists of plants that are unique to each individual park. And the result is surprising, that the historic floras of each of these parks range from 10 to 20% unique flora. And really my expectation there from being familiar with these areas is that, yeah, 3%, 5%, sure, is probably going to be unique to these. Wouldn't have been surprised if it was more than that, but I was surprised that it was 10 to 20%. So each of these parks are gems in their own right, because of this unique flora. And so then I asked the question, well, what can we do with the data? I looked at this 12% of the white tank flora, and what I saw was that the plants that are in that category, half of them are in that list of plants we can't find. And so I think that one of the takeaways from this study could be that the floras of all of these parks are possibly diminishing. It's my conclusion that the flora of the white tanks is constricting. I think it's possible that all of them, that there's sort of a homogenizing effect that is happening with climate change, land use, impacts of invasive and use. So that's kind of where I'm at. And to not end with this bummer, here's my newly named Black Canyon Spring. I think the nicest spring in White Tank Mountains. It's a gorgeous spot shaded by willows. You can even see in the rocks some of the water outlets where, when the spring is at a higher level, where the rocks are feeding water to the spring, you can see an outflow from this where it trickles downstream. It's a really neat place. So that is it. I'll take questions and comments if anybody has any.
Thank you so much, Cass. Yeah, I didn't see any questions pop in through the chat, but please unmute yourself, shout out any comments, thoughts, questions. We have about 10 minutes-ish before the event is supposed to end. But I mean, personally, I thought this is really, really interesting. And also, I mean, I also thought it was very surprising to see that there's about 10 to 20% of unique species. That's really good to hear on my end, because we work so hard to preserve these desert parks and preserves. So to know that there is so much more value to them, and there's so much more that we really do need to protect, I think that was a really great lesson on my end. Very informative from Bonnie. Thanks, Cass. Yeah, so please feel free. Like I said, we have about 10 more minutes. If there's any thoughts at all, I know we actually had some park rangers attend, so hopefully you guys got some really, really great information. Again, this event was recorded, so we will have the entire presentation on the Casca YouTube channel for you all to reference and go back to, because there was a lot of information, honestly, so this is great. And also, Cass, it seems like there's still so much more work to be done. Of course, trips to make, but also just work with the data. There's so much interesting things that I'm sure you're still finding out. So that's really something that we're looking forward to. Hopefully we can hear from you again at some point in the future when you do more work with all these floras. Let's see.
Sure.
Wish I knew where Black Canyon Spring is located. It's motivating me to learn more to identify willow trees. That's one of the comments we have. Let's see.
And Black Canyon Spring is not a joyride. It's tough to get to.
I have the same question. This is a ranger. Wrote it down to ask a ranger next time. Can those maps be set up as a separate file? Let's see here. We do have a question. Can those maps, Steve, can those maps be set up as a separate file? I'm wondering if you can clarify what maps you were referring to.
Yeah, this is Steve. The maps that you had locating, you had various maps that were locating both the springs, the various plants and so on. Those are of interest to those of us who are trying to work with the park system to go after the plants that don't belong there. And having maps like that as a separate thing so that we have them in our hands, so to speak, would be a lot easier than trying to do screenshots all the way through the recording later.
Mm-hmm. Yeah, I can mail those to Anya, and she can get them to whoever.
Yes, please. If you are interested in, I know that Justin, you asked for this information. This will definitely be shared with the county parks. But yeah, if you are interested, Steve, go ahead and shoot me your email in the chat, and I'll be sure to get that info to you. Let's see here. There's a couple more questions. I'd like to hear more about how volunteers helped with this project. Are there similar opportunities in the future here or elsewhere? Cass, I don't know if yeah.
Yes, there are volunteers helped in that often, sometimes volunteers just help by being company or by being sounding board so I can pontificate and talk to someone who is willing to listen. But other times they helped with manning some of the equipment, the plant press and the documentation. Other times it was a safety issue. Some of the stronger hikers in that group could go into some of the more difficult places so that, I wouldn't be alone. So that, and, it's not smart to be in some of these places by yourself. So there's a variety of ways that they help. And just quite frankly, just knowing that that population was there and that cared that much about the park and were interested in its preservation was helpful, was, morally hopeful.
Yeah, and just to kind of a little bit add on to that, as I mentioned at the beginning when I was introducing Cass, we do have, he did take the training that was a budding botanist training that was co-developed with the Grand Canyon Trust, I believe, under the Arizona Native Plant Society. It was then called the Plant Atlas, no, I forget.
Plant Atlas Project of Arizona.
Exactly. Anyway, so we trained a whole bunch of volunteers. Cass and Dawn, like I said, became our lead volunteers and really took the lead and really took this project and just ran with it. And like he said, they did so much work and they took volunteers, other budding botanists or other amateur botanists with them. And so we actually just recently this year gave the first virtual budding botanist training. And we hope to actually make a bigger effort around this and actually do another budding botanist training next year. So I welcome everyone who's interested to just keep their ear out for when that would happen. And of course, the opportunities after you've been trained of what might come for another flora or other kind of floristic inventory work from our partners or ourselves. But yeah, so we have one more question around invasive species. Is there a thought about eliminating the invasive species you found? So yeah, I'm going to just chime in real quick around the invasives. There are a lot of really, really amazing organizations that work around the White Mountains and around other mountains in the valley that do a lot of invasive species work. Steve, I know Jim's here from the White Mountains Conservancy. If you are around these mountains and are interested in helping with invasive species management, removal, the mapping of it, all of these are really key activities that we do in order to manage those invasive species that are found. It's really tough work, but I welcome you to, like I said, if you're interested in the White Mountains, to go ahead and look for our partners, the White Mountains Conservancy. They have a lot of really great stuff going on. If you're in different parts of the valley, there's different organizations, but I welcome you to visit our website. Will you ever do the west side of the mountain? One last question here from Jane.
Yes, I do plan to go to the west side. It'll be a tentative things to begin to put some pin drops down there and characterize the flora. My expectation of the west side is that it's going to be a less rich version of the east side, but the west side does hold out some possibility of having a flora profile that maybe resembles a little bit more of Western Arizona and the Mojave. So I want to look at it at least close enough to characterize it in that respect. But the west side is really tough to get to. It's nice if you're driving somebody else's car, not so nice if you're driving your own. It's rugged and remote. But that is an area that in the next couple of years, we'll be making as many trips as I can into before we call it quits.
Awesome. All right. And I am putting just a little bit more information in the chat for anyone that's interested for the White Mountains Conservancy. I'm also going to put information about our Desert Defenders program, which is also around invasive plant species. One more comment from Lisa Cass. Are you aware of a BioBlitz that Arizona Game and Fish is planning for April 2022? I would imagine, Lisa, instead of 2021, in the Hasayampa area west of the mountains. You would be a great participant for that. And actually, yes, Cass, thank you, Lisa, for reminding me on that. And anybody who's interested, really, Arizona Game and Fish is planning a big bio blitz next year for, like Lisa said, the west area of the mountains in the Hasayampa. We hope that it's a big effort to learn more about all the different kinds of plants and wildlife that live in that area. Lisa, do you know if there's any like online information that I could just quickly shoot to the chat so Cass can have that?
And I'd be really up for that. One morning is I got married last year, and most of my time is spent in Oregon, but I do go back to Arizona several times a year, both to do collections trips and to, take care of the house. So I'll have to time this any trip that I do that has a schedule associated with it. But if I know ahead of time, I'll plan on doing it.
Yeah, well, Lisa said not yet, coming soon. So obviously, when I hear about a cast, I will shoot you a word and let you know. Congratulations, by the way. So that's really exciting. And then, Lisa did share her email in the chat for you, Cass. If you're ever interested, please email me and I can give you more information. And we can stop sharing screens too if you need to grab that from the chat. But I think that is it. If there's any we have 1 more minute. If there's any last questions, please feel, like I said, just go ahead and unmute yourself and share your thoughts. But yeah, we'll go ahead and kind of wrap things up. Like I said, I shared a couple links in the chat to the conservancies, the different programs. And I also, at the beginning of the talk, shared a link to SciNet, which Cass referenced and mentioned a couple of times throughout the presentation. That is an amazing, amazing resource. I actually shared a direct link to the Floras, all of the different parks that have Floras that have been done of them. So I invite you to explore that. But like I said, overall, this presentation has been recorded. It will be on the Cascade YouTube early next week. But thank you all so much for joining. Thank you again, Cass. That was a really wonderful presentation. And I'll be in touch with a couple of folks after this that want some information. But yeah, thank you so much. I hope you all have a great rest of your week.